Sorry, I started recording this late. This was the first problem. This is from the FIP quiz that was online for stock system nomenclature 122.15. Okay, so we had iron 2 oxide, and now we're dealing with how do we write a formula for tin 4 oxide. Well, we write our ions, and we crisscross the charges, and that gets us a 2 and a 4. That can be simplified. So this becomes SnO2. Okay, that's tin 4 oxide. Next, we want to write a formula for copper 2 chloride. Again, we start off by writing the ions. That's our basic step. That's the first thing we do always. Cu2 plus, Cl1 minus. Crisscross them. We get a 1 and a 2. We eliminate that 1 when we simplify. We get CuCl2. Okay. What do we call this thing? Okay. Again, if you're still using the training wheels, you probably wrote down here cobalt something oxide. You know, and let me make clear, even though you're doing these online, you can and probably should have a blank piece of paper with you. I don't expect you to do these in your head, you know. Like your periodic table on a blank piece of paper is good because especially if you're still a little bit shaky on these, you need to write down the steps. You don't, you know, I wouldn't send a toddler out on a bike on a highway. You know, I wouldn't suggest that you send yourself out in a similar situation. Put the training wheels on and take a side road, you know. Like, it's okay. These are FIP quizzes. These are side roads. This is why we're not throwing you into a test. So then we're going to do our reverse crisscross. We know cobalt will be positive. Oxygen will be negative. We get a 3 and a 2. That, oops, how did I do that? Cut that out of there. Oxygen does form a 2 minus ion, so that hasn't been simplified, so this is cobalt 3 oxide. Okay, and what do we call this stuff? MnF3. Well, and this was a little bit tricky, but I don't think I got any of you. Manganese something fluoride. Excuse me. Thank you. Thanks. More to come, I'm sure. And if we reverse crisscross, we would get a 1 and a 3. Fluoride does form a -1 ion, so we would assume this hasn't been simplified. So this is manganese 3 fluoride. I threw in magnesium just to be mean, or maybe actually nice, because hopefully you went, oh, that's not magnesium. Magnesium is group 2. That always forms the same ion. Blah! Moser! Right? Okay. I haven't looked at the results yet in detail, so I don't know if anybody fell into my trap. I did. Okay. Well, now you know. I'm that mean. Nickel 3 oxide. What's the formula? First thing we do, write our ions. Nickel 3 plus, oxygen 2 minus, crisscross. This is one of those ones that I like, the 2 3s. So Ni2O3 is nickel 3 oxide. And lead 2 sulfide. Okay, write our ions. Pb 2 plus, S 2 minus, Pb with a subscript, S with a subscript, 2 and 2, which means they simplify and we get PBS. Huh, public broadcasting system. Okay. What do we call this stuff? Nickel, or NiBr2. Okay, if you're still using the sort of training wheels, if you're kind of taking it easy on yourself, you probably jotted down something like this. So it's nickel something bromide. Well, Ni with a something charge, bromine with a something minus charge. 2 and 1. Does bromine form a 1 minus ion? Yeah, that's correct. So this is nickel 2 bromide. Okay? The common traps to fall into. One of my personal favorites. Copper 2 chloride. Oh, I see. Copper 2 chloride. No! No, 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 no. Don't do it. Don't fall into that. Because people read this and they think, oh, copper 2 and then chloride. No, it's a copper 2 ion. So you have to make sure, and so I put those on there very intentionally because I want to make sure you're not doing that. Remember that that copper 2 designation is a designation of the charge on the ion. Okay, questions, comments, concerns? We're going to talk about polyatomic ions. So up to now, we have been talking about monatomic ions. Monatomic ions are made up of how many atoms? 1. Poly means more than 1, yeah. These are ions that are made up of more than 1 atom. So what you have is something that's covalently bound, but then as a group, they either give up or they gain electrons. More than 1 atom, covalently bound together, they as a group give up or gain electrons, so they overall have a charge. And you have already dealt with some of these in terms of doing Lewis structures for them. So, for instance, our old friend, you just had this on your test. I just drew it very badly, very quickly. This is a sulfate ion. So the sulfur and the oxygens are sharing electrons, they're covalently bound, but then as a group, they have absorbed 2 extra electrons from out in the world to make everybody happy. Okay, sorry, I dropped an electron there someplace. Whoops. Okay, so to make everybody happy octet-wise, they've gained a couple extra electrons. And so we have this nice stable configuration. Now, that's great. They behave the same way that other ions do. That is, they form compounds with things that have opposite charges that balance them. Okay? So, again, just like when we're doing binary ionic compounds, the name of the thing, of the compound itself, is just the name of the 2 ions. The name of the compound is just the name of the 2 ions that are forming the compound. So let's do a nice, easy one, shall we? So you understand what polyatomic ions are. Okay, we're going to start off with some simple ones, and then we'll go back and talk about all the nuances. So if I tell you that I have sodium, whoops, I have a bunch of sodium ions, that would be Na 1 plus, and I have, let's see, this ion. This is a polyatomic ion. Cn has a 1 minus charge. Cn is called the cyanide ion. Now you can see right here, I think, all of you, how this would form a compound. This is NaCN, and it's called sodium cyanide. Okay? It's a combination of sodium ions and cyanide ions. Okay. So the very basics, the name is just the name of the 2 ions. We're going to do lots of formula rating today. Okay, that's fairly straightforward. Let's go back and talk a little bit more about some of the nuances of the polyatomic ions you're going to be working with. Okay. So the chart that you have on the back of your periodic table that I gave you, what I'm calling your ion Bible, this has got the common polyatomic ions. There are other polyatomic ions, but these are ones that crop up a lot, that we use a lot. Most of these are oxy and ions. So oxy, they contain oxygen, and ions, they have a negative charge. There are a few exceptions. There are 2 on there that are polyatomic cation ions. If you would be so kind as to look at your chart, find the 2 polyatomic cations. So the 2 polyatomic cations are ammonium, which we will use all the time, and dimercury, which we very seldom use. So ammonium, you drew this. You built, I think you built this. No, you built ammonia. But you've drawn ammonium, and let's draw it right now. So the ammonium ion is a nitrogen bound to 4 hydrogens, and it's got a 1+ charge. That's the ammonium ion. Those things are bonded covalently. You can't separate them. These brackets are going to be a useful psychological tool when you're doing ionic formulas with these guys. Okay, but enough about that. Let's talk about the oxy-and ions. So, if you look at your chart, let's look down that first column. You'll notice that these are arranged by charge. So the first column in that common polyatomic ions is you've got your ammonium at the top, +1. Then you've got 1-, and there are a ton of them. There are a bunch of polyatomic oxy-and ions that have got 1 extra electron. So they have a 1- charge. You'll notice that you have chlorate, chlorite, and if you go a little bit further down the list, you have perchlorate. Boy. Now, I didn't give you hypochlorite. There are 4 of these puppies. And all they are is chlorine and oxygen, but it's different numbers of oxygen. Okay, great. Now I'd like you to draw your attention to nitrate and nitrite. And sulfate and sulphite. Now these are in the second column. These are 2-. Well, look at that. So the immediate thing that a lot of people want to do, and I remember wanting to do this, is say, oh, okay, well, if it's got 3 oxygens, it's 8. And if it's got 4 oxygens, it's something else. And if it's got 2 oxygens, it's 8. Sadly, it's not that simple. The way the naming convention on these works is that whatever is the most common ion gets the ATE ending. So between nitrate and nitrite, guess which one's more common? Nitrate. Of all of the possible combinations of chlorine and oxygen that form polyatomic oxy-and ions, the most common is the chlorate ion. Now in this case, that's ClO3. Whatever has 1 less oxygen than the most common gets an ITE ending. Remember when I said you needed to pay attention to the IDEs, because soon you would also have ITEs and ATEs to keep track of? That time is now. It's okay, you'll all survive. Now here's the good news I have for you. You don't ever have to memorize that. I don't expect you to memorize that, because I think it's stupid. You're going to use your reference sheet always. You're going to look these things up every single time. So you'll know on some level that, oh, ATE is the most common ion, but you don't have to remember that. You're going to look it up, and by the time you've looked it up about 60-some times, you're just going to know it from using it. Okay. We won't talk a whole lot about the hypochlorite and perchlorate. That's, so this is most common, -1 from most common, -2 from most common, +1 from most common, okay? The most common gets the ATE, 1 less oxygen gets the ITE, 2 less oxygen gets the hypo-ITE, and then if we go with 1 more oxygen, we get a per-8. Don't spend time memorizing that. Don't worry about it. It's something for you to know. What we want to do now is practice making compounds with polyatomic ions. So let's get started, shall we? We will start with naming because it's easier. So let's do this one. This is something that we commonly find in cured pork products such as bacon, ham. Hot dogs have this in them. It's also a component of gunpowder. The name of this substance is the name of the two ions which make it up. The trick to naming polyatomic ionic compounds is just seeing the pieces. Now, obviously, you all know that sodium is one of those discrete chunks. And you're going to know by the end of, well, today, that this is the other chunk. You're going to recognize, you're going to look at that NO3 and go, oh, that's a polyatomic ion. You don't have to know which one. You just have to know that that's a polyatomic ion, and I'm going to write the name for it. That's all it is. So the name of this substance, write it down on your paper if you know it. Share it with a friend. I'm hearing whispers of sodium nitrate. Yes? Okay, good. Okay, CaCO3. Remember, the first challenge is making sure you're seeing the chunks. Write the names of the ions. That's it. All right, so calcium carbonate. All right, good. Fantastic. Now, let's do something just slightly more interesting, and by more interesting I mean slightly more complex. Let's do well, this isn't the complex case yet, I guess. Na2SO3. Oops, I wasn't recording. Sodium sulfite, again. This just tells you how many sodium, what the ratio is. It does not change the name. In ionic compounds, there are no prefixes and suffixes. You're only using the name of the ions. Okay, let's do one more, and then we'll turn around and we'll do some formula writing together. Okay, so let's do MgNO3 two times. Are you all saying that this is magnesium nitrate? Excellent. That's what it is. It's magnesium nitrate. This is an ionic compound. We do not need any... Let me record this. Yeah, the fact that there's a little 2 here doesn't get reflected in the name. That's just showing the ratio of nitrate ions that are needed to balance the charges for every magnesium ion. So, let's do some formula writing, shall we? Yay, I know you're so excited you can hardly contain yourselves. Okay, you got your polyatomic ion charts ready? So if I tell you that I have potassium chlorate, just like with writing binary ionic compounds, my very first step is to write the ions that I'm dealing with. So the potassium ion is K charge 1 plus, right. Okay, so K1 plus. The chlorate ion is formula Cl O3 1 minus. Okay, wunderbar. Our second step, just like with writing binary ionic compounds, our second step is to do that crisscross. So leave a space for your charges. Crisscross, whoops, classic mistake. Crisscross them when we get 1 and 1. Can we simplify that? Why, yes we can. KClO3. Remember that this is a distinct unit of its own. Okay, sodium chromate. Step 1, write your ions. Sodium is charge 1 plus. Chromate ion CrO4 what? 2 minus. Second step. Crisscross. Okay. Third step, simplify. Sodium chromate. Okay, so thus far what we have not had to do is we have not had to have multiple polyatomic anions. The polyatomic ions so far have always had a subscript of 1. Do you think it might be more confusing when they don't? Yeah, it is. Magnesium bromate. Let's talk first about one of the real obvious traps here. This is magnesium bromate. It is different than magnesium bromide. Watch your endings. First step, write your ions. Magnesium is Mg2 plus. The bromate ion is BrO3 1 minus. When you do your crisscross here, make sure that the space you're leaving for whatever subscript you're going to have on the bromate ion is well clear of this, because you don't want to get mixed up. 1, 2. Now, remember that this is a discrete unit. You have to enclose it in parentheses. So this is Mg BrO3 2 times. Okay? Sure. If you say so. Mg BrO3 2 times. So that's magnesium bromate. Now, traps that people fall into. Coming from math. Oh, I can distribute that. I multiply everything, and that makes it Br2O6. No, 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 no. Remember, when we built polyatomic ions, this is a discrete structure all to itself. You can't break it up. This is, in essence, a molecule that has gained an electron. You can't change the formula for the polyatomic ion. Most of you will probably do it once and then go, oh, and never do it again. But be watchful of that. Okay, let's do one more together, and then I could turn you loose to work on your own. We'll do 2 more together, because there's one other example I want to do. Ammonium nitrate, commonly found in fertilizers. So you write out the ions. Ammonium is a polyatomic ion, which is NH4 1 plus. The nitrate ion, somebody I have not heard from yet. Justin. NO3 1 minus. Yep. 2, do your crisscross. NH4 with a space. NO3 with a space. 1 and 1. Simplify it. NH4, NO3. Okay. Now, let's do one that's just a little bit more challenging. Ammonium sulfate. Go. Step 1, write those out. Okay, you should all have NH4 2 times SO4. Okay. Now, one note before I turn you loose to practice. One thing that I've had students want to do in the past is leave everything in brackets, even if it's not, so even if it's sodium nitrate. They want to do that because it helps remind them that that nitrate is its own thing. Can you do that? Is it legal? Is it proper? Well, okay, it's not illegal. It looks stupid to a chemist. You don't really care about that probably. If you find that you're having a hard time remembering that the polyatomic ion is its own thing, go ahead and put it in parentheses. When you get to Gen Chem in college, you might get made fun of, but you'll be tough and big by then, so you'll just say, if it helps you, if you find that you're making errors that would be avoided with this, go ahead and do it. And it's like training wheels. You'll outgrow it in all likelihood. But if this helps you as an intermediate step to getting good at these, then do it by all means. Okay, practice problem. Okay, practice problems on page 211, 1 and 2. Those are just on your own. The answers are there. I would recommend those. You will, of course, have a FIP quiz tomorrow. And added on to the homework, you will have 20, let's see. $24 and darn it. Page 211, and then the practice problems 24 and 25. And let me look and see. I may have an additional practice worksheet for these. I'll check.